We are going to learn the difference between Z distribution versus T distribution using Excel. Z distribution is used when the standard deviation is unknown of a population, right? And they largely when you have a n higher higher than 30, that supports the central limit theorem, and it is good to have. And the prerequisite for the Z distribution is standard deviation must be known. On the other side, the flip side is that T distribution. T distribution when the standard deviation is unknown, or the sample size is or the sample size is smaller, then we can use T distribution. And whenever we say 95% confident default, we remember the value of 1.96, right? So you don't need to remember all the value, even if you dynamically, if it is changing, let's say 95.5 or 99.99, we can easily get the values from Excel. How to do it? So first of all, this is a confidence level. The more the confidence level is there, so it like a net, and where you can put fish net where you can accommodate more and more fish, right? So when you have more bigger net, exactly the same thing, confidence interval, bigger confidence interval will accommodate more and more the fish, right? So in the net. So the alpha is basically is 100 minus the confidence interval is alpha. For example, 99, it will give you 1%. Let's say 95, 5%, and so on and so forth. So largely only these values been used, whether 99 or 95 or 90. But these are all very rarely are not used. Okay, this is the value, but I have just populated in order to explain the Z value also as well, right? So this is the alpha value, as you can see here. And the Z value, the formula is very, very straightforward in Excel. And all you need to do is that you need to put norm. There are two, formulas coming. This is distribution. So it will return the normal distributions and all that. But here we need to use inverse. Return the inverse of the standard normal distribution, right? When you say normal distribution, the prerequisite is that mean is 0 and standard deviation is 1 in ideal case, right? But here we need to use not this formula, not the normal one, but inverse of the standard deviations we need to use, or normal distribution we need to use. So 1 minus, so alpha divided by 2. So this will give you the Z value. For example, if you say 99%, Z value shall be 2.58, and then drag it up. And you got the same value, 95% mean, you get 1.96, right? For example, let's say you want 95.5 example, right? So that means 2, and so on and so forth, right? Let me keep retain this with the 95%, right? And then if you want 99.99, you will get 3.89 and all, right? So easily we can easily get it. So this is all about Z distribution. So Z distribution, whenever you have anything, you don't need to refer the matrix and all that. Directly you can pull up this formula in Excel. Norm dot S dot inverse 1 minus alpha divided by 2, it will give you the value. Another one is the T distribution. As we learned, that T distribution is used when the standard deviation is unknown. And we need a couple of things before we could do that, because here N will influence the degree of freedom. In other words, N or in degree of freedom will influence the T value, right? So this is here, we're not talking about the data set and all that, right? We assume that the standard deviation is known, right? The standard deviation considered the N. But here, so since the standard deviation is unknown, but we need to find out the degree of freedom. Degree of freedom is actually N minus 1. For example, let's say if you have a sample size of 30, 30 sample size you have, that means 29 is the degree of freedom. And 81 mean 80. Just simply degree of freedom N minus 1. Okay. And then we can substitute this formula. So let me go ahead and do it. So the formula is T dot inverse. Again, this is also inverse into 2t, because we are talking about return the two-tailed inverse of the students T distributions, right? And then here we can write probability. Probability, you can write what is the alpha value. So alpha value, when you say 99%, we are saying like alpha is 1%, right? And degree of freedom, here we can input the degree of freedom. So here is this, and then give OK. So 2.76, I will keep it only 2 digit now. I'll drag it. So now you see that if it is, when you talk about the 95% confidence of Z distribution, so the value is 1.96. The same thing, the value is slightly higher, so 2.05. So how much higher? We can easily see here. What I'm doing it, I'm just keeping everything in percentage. For example, the difference between the Z test, I'm just highlighting this one. If you look at 95% confidence, we know the value is 1.96. T distribution will give slightly higher, 4% higher, 2.05. The most influential factor is that N, right? N will influence it, right? So what I'm doing is instead of 30, I'm just reducing below 30. Let's say I'm just giving only 10 samples. So what will happen naturally? The T value will increase because I have a very, very small sample, right? Let's say 5, even it will go higher. So you see that 1.96 here, 2.78, and almost 42% is higher, right? So let's assume that I'm just going back like 300, and this is what 4% difference we saw. And then let's say I'm just adding it 100. So the difference is coming lower and lower. Between these two, the difference is coming lower and lower. You may ask this question, at what point the value will get 1.96? So you have to have at least 10,000 samples in order to get it. Even if you have 1,000 samples, still the difference will be, you have a difference of 0.1 percentage, right? So, and then if you have 10,000, there it exactly coincides thing, right? 1.96 you get it, and with the this also T value also 1.96 if provided n equal to 10,000, right? But however, this is just one factor that when the Z value and T value coincide, when you have T value, the sample size is 10,000, then it coincides, right? So the idea is that whenever the N value will change, automatically the T value will change. This is the difference. More or less, you always get the T value is equal to or slightly higher than Z value. That's what it means, right? What I'm doing it, I'm just creating the random between function here. So just to indicate this, the difference, what I'm doing it random between, and I will keep the sample between 300 to 10,000. I'll keep it. So you can see here, whenever I go higher, the difference is lower, right? If I keep it like very small one, maybe I can put like between 300 to 100. And if you see here, so the difference is between 0 to 2%, right? If I keep if I keep between 10 to 30, the difference is gonna be very, very huge. You see that yeah, the difference is going to slightly getting a higher up, right? So this is what it means. And then what I'm doing it, ideally, I have to look for minimum 30 as sample size, and then 100, and I can go beyond 100 also as well, right? So this is, then you can keep it like 88, minus 1 is 87, and then T value is 1.45. The same thing, Z value is 1.44, and the difference is only 1% or so, right? So this is how we can easily identify the T distribution and Z distribution in Excel. I hope you find it useful. Please do like, share, subscribe my channel. You have a wonderful day.